Hey students, this is Alex from Me2 Education here. In this video, we're going to be covering the foundations of solving equations. So put on your headphones and let's zone in. Now note, this is part one of a two-part series. The second part will more focus on multi-stepped solving equation strategies. Here, we're going to be mainly focusing on the foundations in part one. Now, the key rule for this lesson to understand is that whenever you're moving something over the equal sign, you need to do the opposite of whatever it's doing to the variable. And today, we're going to apply this concept to addition, subtraction, multiplication, division, and square numbers. Let's start with questions that have addition in them. For example, x plus 7 equals 10. Now at first glance, this will seem very easy to all of you because we know that x is going to be 3. However, the purpose of today's lesson is to have a look at the foundations. What are the steps that we would need to take to ensure that we would get an answer that has 3 with all the working out possible? In this case, the purpose is to isolate this x over here. So by isolating this x, we need to ensure we have to move this plus 7 over to the other side. Now in our key rule, we talked about doing the opposite. Now what is happening to the x? The x is being added to 7. So to move this plus 7 to the other side, we're going to do the opposite of what it's doing. The opposite of plus 7 is to minus 7 from both sides. In that way, we will have a plus 7 and a minus 7 that will cancel out. And on the other side, we will have x is equal to 10 minus 7. And from here, we can see that x will equal to 3. And that is the full working out of how to solve equations with addition. Let's do another one for addition. Let's say we have x plus 23 is equal to 28. Now here, let's again see what is being done to the variable. We have plus 23 that is being done to the variable. We want to isolate or keep this x by itself on this side. So the purpose will be to move this plus 23 over to the other side. To do this, we need to do the opposite. So instead of plus 23, we minus 23 on both sides, like so. In this case, plus 23 and minus 23 will cancel out. And then we get x is equal to 28 minus 23. From here, we can see that x will equal to 5. And that is the full working out of how to solve equations. Let's now move to subtraction. For example, x minus 8 is equal to 15. So in this case again, the purpose is to isolate this x, and to do that, we have to move this minus 8 to the other side. To move this minus 8 over the equal sign, we do the opposite of what is being done to the variable. The opposite of minus 8 is plus 8, and we do that to both sides. In this case, minus 8 and plus 8 will cancel, and we will get x is equal to 15 plus 8. In this case, x will equal to 23. Let's do another one for subtraction questions. Let's say we have x minus 14 is equal to 24. Now again, the primary goal is to isolate this x. To isolate the x, we have to move this minus 14 over to the other side. To move things over the equal sign, we have to do the opposite of what is being done to the variable. The opposite of minus 14 is plus 14, and we do that to both sides. In this case, minus 14 and plus 14 will cancel, and you will get x is equal to 24 plus 14, like that. And in the end, your answer will be x equals to 38. Let's now move to division. For example, let's say we have x over 20 is equal to 8. Again, the primary purpose is to isolate this x, and to do that, I need to get rid of this divide by 20 and move it to the other side. So we have to think, what is the opposite of dividing by 20? The opposite of dividing by 20 is to multiply by 20, and we do that on both sides. By multiplying both sides by 20, on the left-hand side, we can cancel out this 20 and this 20 because multiply and divide are opposites. In this case, you would get x is equal to 8 times 20. And from here, we can see that x will equal to 160. Let's do one more for divide. Let's say we have x over 5 is equal to 10. Now in this case, again, the purpose is to isolate this x, so keep it by itself. To isolate this x, we have to move this divide by 5 over to the other side. Now to move things over the equal sign, we need to do the opposite of what is being done to the variable. Because this is x divided by 5, the opposite of divided by 5 is multiply by 5. And we do that to both sides. In this case, multiply by 5 and divide by 5 will cancel. And that way you will have x by itself. And on the other side, you would have 10 multiplied by 5. From here, we can see that x will equal to 50. Let's now move to multiplication. Let's say we have 5x is equal to 30. Again, let's go back to our basics. The primary purpose is to isolate this x. To isolate this x, we have to get rid of this 5. This 5 is being multiplied by x. And if we want to move this 5, or multiplied by 5, over to the other side, we need to think, what is the opposite of multiplying by 5? The opposite is dividing by 5, and we do that to both sides. In this way, multiply by 5 and divide by 5 will cancel, and we will have x is equal to 30 divided by 5. And from here, we know that x will equal to 6. Let's do one last one for multiplication. Let's say we have 8x is equal to 24. Again, the purpose is to isolate the x, so keep it by itself. What's attached to this x? We have multiplied by 8. We have to move this multiplied by 8 over to the other side to keep this x by itself. So we need to think, what is the opposite of multiplied by 8? The opposite is divide by 8. And we do that to both sides. From here, our multiplied by 8 and divide by 8 will cancel, giving us just x on this side. And on the other side, we will have 24 over 8. And then from here, we know that our answer will be x is equal to 3. Let's now move to the final type, and that is squares. Looking at squares, let's take, for example, x to the power of 2 is equal to 36. Now, for those of us who would know, we know that 6 squared will give us to 36. But how do we actually show the working out for this? So again, the primary purpose is to isolate this x. So in this case, I need to move this squared over to the other side somehow. Now, the opposite of a square is to square root, and we do that to both sides. By square rooting x squared, we can actually cancel out the square root and the squared. That will leave us with just x on that side, and then we'll have square root of 36 on the other side. And from here, we know that x will equal to 6. Let's do one final example. Let's say we have x to the power of 2 is equal to 100. Again, the goal is to keep this x by itself, so I need to move this squared somehow over to the other side. To move the squared over to the other side, I need to do the opposite. The opposite of squared is to square root, and I do that on both sides. That way, the square root and the square will cancel, leaving x by itself, and on the other side we would have square roots of 100, and x equals 10. Now that we've gone through the different foundational skills for addition, subtraction, multiplication, division, and squares in how to solve them in equations, let's have a go at putting this into practice. See you on the other side. Alright, hope you've had a go at some of those questions. Let's go through these together. So let's start with question number 1 over here. X plus 22 is equal to 40. The purpose is to find x, and to do that, we need to isolate this. To isolate this, I have to move this plus 22 over to the other side. Whenever we're moving things over the equal sign, we need to do the opposite of what it's doing to the variable. The opposite of plus 22 is minus 22, and we do that to both sides. In that way, plus 22 and minus 22 will cancel, leaving us with x is equal to 40 minus 22. And in this case, we know that x will equal to 18, and that is our final answer. Let's move to the second question. Our second question has x minus 50 is equal to 101. Again, we have to isolate this x or keep it by itself. To keep x by itself, I need to move this minus 50 over to the other side. To move it over the equal sign, I need to do the opposite of minus 50. The opposite is plus 50, and I do that to both sides. In that way, minus 50 and plus 50 will cancel out, leaving us with x by itself on the left-hand side, and on the right-hand side, we will get 101 plus 50. This will leave us with an answer of 151. Let's move now to the third question. The third question is 10x is equal to 2000. Here, again, we would need to isolate this x. To isolate this x, I have to get rid of this 10 and move it to the other side. Now this 10 is being multiplied by x. So the opposite of multiplying is to divide. And so I'll divide both sides by 10. That way, this multiply by 10 and divide by 10 would cancel, leaving us with x is equal to 2000 over 10. And we know that 2000 over 10 is equal to 200. Let's now move to the next question, which is up here. We have x over 6 is equal to 4. So the purpose is, again, I have to keep this x by itself. To keep this x by itself, I have to move this divide by 6 somehow to the other side. To move things over the equal sign, we have to do the opposite. The opposite of divide by 6 is to multiply by 6, and we do that to both sides. In this way, multiply by 6 and divide by 6 will cancel, leaving us with x is equal to 24. Let's now move to the final question, and that is x squared is equal to 225. The goal here, again, is to keep this x by itself. To do that, I need to move this squared over to the other side. What's the opposite of squaring? That is to square root, and I do that to both sides. That way, we can cancel out the squared and the square root, leaving us just with x by itself on the left-hand side, And on the right hand side, you would get square root of 225. And the answer of root 225 is 15. And that is our answer. I hope these fundamentals helped you gain a bit more confidence in solving equations. In part 2, we'll cover some more complex examples where we'll need to perform multiple steps to get us to the answer. But if this helped you, give us a wave comment in the comments down below. This is Alex signing off for now. Stay sharp.